Huh. Fine. Is that clear till this point?
Yes, sir.
Yes.
Yes, sir.
Om, I will be coming to your question, but before that, since we are talking a lot of circular motion, I would like to just briefly remind you of all this. So I suppose x-axis, y-axis, and the particle is rotating in the circle of radius r. And you can see here O, the circle with O. That means it is omega bar is out of the board.
Out of the screen, yes, sir.
Out of the screen, right?
Yes, sir.
And the axis is along the plus kth direction. So
Yes,
plus
sir.
kth direction is what?
Outside
Outside the board.
Outside the
X
Yes.
cross Y, it is coming outside. The screw is coming outside. So axis. See now, you see we have discussed the circular motion earlier, but with the difference now that I am including the term axis.
Yes, sir.
So the axis is perpendicular to the plane of rotation, and see, remember now, axis is perpendicular to the plane of rotation, and what else? Dash dash. Don't see my face, look at the board.
axis also.
Axis is perpendicular to the plane of rotation, and
Velocity and velocity.
and
X
passing through the center.
passing through.
Oh, passing through this. Okay.
Now,
Yes, yes.
okay, understood? See,
Yes, sir.
so please be reminded now. It is not just sufficient if you say, oh, it's passing through the axis is perpendicular, but you should also now locate its position where it is passing through. It's passing
Yes.
through the
Yes.
center. Okay. Now you can see here, there is r bar, there is theta. What is theta here?
Angular displacement.
Angular.
Excellent. Angular displacement at time t.
Yes, sir.
And what is v bar?
Velocity is
Velocity vector at time t.
Yes, sir.
Understand? Because these are all variables. And what is r bar? Position vector at the time t.
Of period point. Yes, sir.
At the time t.
Yes.
Okay.
Yes.
Then since it is performing circular motion, obviously
Yes.
it should have radial acceleration, and if
Yes, sir.
it need not have tangential acceleration,
Yes.
but if it is if omega is not constant, then it will also have tangential acceleration.
Yes, sir.
Right?
Yes, sir.
So keep all these points clear, and you can represent it in polar as well as the what? Cartesian coordinates. And I suppose you should be able to get the relation. And here, if this is performing pure rotation, then there is no alpha. That is, uniform circular motion. Then alpha is 0. Alpha is what? d omega by dt.
D omega by dt.
Yes, sir.
So if there is d omega by dt, you will have alpha bar. Okay, and you can see here alpha bar and omega bar are both coming out of the circle.
Yes, sir.
What does that mean? What does that mean? Alpha bar is a vector which is perpendicular to the plane and coming out of the board. What does it mean?
Accelerating. The velocity is increasing. Angular velocity is
The angular velocity is
increasing.
increasing.
Yes, sir. Yes.
Okay, the angular velocity is increasing, right? Fine. So you have to keep looking at that, because I suppose you understood the meaning of this, because you see that means now the speed along this point is increasing in this direction, in clockwise direction.
Yes,
The
sir.
speed of the particle is increasing in the clockwise direction. Then
Yes, sir.
alpha is positive.
Anti-clockwise direction.
Anti-clockwise.
Yes,
Sorry,
Yes, sir.
anti-clockwise. Anti-clockwise. This is anti-clockwise. Anti-clockwise. It is positive. Okay.
Yes, sir.
It can it be possible that omega bar is out of the board and alpha is into the board?
Yes.
It is
Yes,
possible.
sir. Yes, sir.
When?
When the particle is decelerating.
When the speed of the particle in the anti-clockwise direction is decreasing. See, you make it very clear, decelerating and all, be careful. Okay,
Yes.
because it can give double meaning.
Yes.
So here you see the speed of the particle. See, it is better to use this concept of speed. The speed of the particle along the circle in anticlockwise direction is decreasing. So that means now omega is still positive. That means it is out of the board, but alpha will be into the board.
Yes. Sir.
Please become familiar with these things, because see, now circular motion will become a part of this of this rotational motion of a body. Circular motion concepts will become a part of the rotational motion of a body, because every particle in a rigid body, if it is rotating, then every particle is performing circular motion. And now you should see, you should try to group them and see what are all the common things, by which we can get better abstractions.
Yes.
Okay, come closer to the reality. Now here, all these things, theta, angle, vector, axis of rotation. Okay. Now linear parameters: r bar position vector, dr bar linear displacement, theta angular displacement, and theta angular displacement. Dr is r d theta, that is relation between the two. V bar is dr bar by dt, omega is d theta by dt. V is equal to omega bar cross r bar, and V is equal to omega r. Okay. Now,
So that
A bar is equal to dV bar by dt, alpha is equal to d omega by dt, so on and so forth. A is equal to AT plus AR, and AR is omega bar cross V bar and alpha cross R bar.
Yes.
I suppose you can locate the vectors and do the
Yes.
cross, and you can get the direction.
Yes.
Right? Yes, you had a question.
sir, not question. That time we said that theta was angular displacement, the angular position. That was
Yes, at that instant of time.
that distance. Full and
At that instant of time, it is the position. Yeah, I told what is r bar. I told r bar is the position vector at time t. So theta bar is also angular position at that time. Now I have a question to all of you. Now, what is r bar? R bar is a vector in this direction. Can you see?
Yes, sir.
Yes, sir.
R bar is a vector in this direction, but it is given here V bar is dr bar by dt.
Yes, sir.
Is it right?
Yes.
Is it correct?
Yes, sir, it's correct.
One person says it is correct. What about others? Think, all of you think for a couple of minutes.
X.
Is it right? How many students say it is right?
X.
Correct.
So Om and Srijan are telling it is right. What about others? Others are quite okay. Now, one of you two who said it is right. Now, see, I'm just trying to tinker you. Okay, that is, if I say this is r bar, so the circle is like this, and this is r bar. Okay. Now, here this is v bar. Correct? Hello.
Yes.
Now it is given. See, and v bar is perpendicular to r bar.
Sir.
So how can v bar be equal to dr bar by dt?
The direction of dr bar is along these.
How?
Sir, changing.
Right?
Sir, we use triangle of our.
Yes, sir.
We will take R1 bar and R2 bar, sir. We'll find delta R bar using the triangle of vector addition. And now we'll decrease the time interval so that the delta R bar keeps getting smaller and smaller, sir. And at the limiting case, we'll get the resultant vector will be perpendicular to the radial vector.
Yes.
See, that you used it to get what? To get the centripetal acceleration. You use that entire thing to get the centripetal acceleration. Isn't it?
Sir, no, sir, no, sir.
That is what you did. To the derivation of centripetal acceleration, this is precisely what you did.
No, sir.
You had this, right? So you took this R1 bar, this took this as R2 bar, okay?
Yes,
And this as theta, okay? Remember that, okay? And this one you take it as R2 bar minus R1 bar, and it is very close to one another. All that you did to get what? The centripetal acceleration.
Yes,
But here I am asking you V bar is equal to dr bar by dt. See, r bar is in this direction, man. V bar is in this direction. How?
Dr and r bar are different also.
Different, huh? Then how can it be true? See, you justify. How is it right or wrong? If it is right, why it is right?
This correct, sir. So now dr bar, sir, we can delta r bar will be r2 bar minus r1 bar.
No. If you go by that approach, you will go to acceleration and then come back to that. No, you are telling R2 bar minus R1 bar. Okay, that is delta R bar. That is delta R bar. Okay, you say delta R bar is equal to R2 bar minus R1 bar. Okay, and this divided by this one will give you R2 bar. Okay, you are telling this is equal to R2 bar minus R1 bar. Okay, that is this vector, and this divided by delta 3. That you are telling it is V bar.
Yes, sir.
Achha.
Yes, sir.
That is precisely what you are telling.
Yes, sir.
Okay.
NCET.
Okay,
Yes.
fine, I accept it. But by any other means, can you get the same thing? Because I would like to put it like this. See, what is R bar? What is R bar? R bar is R cap.
Yes, sir.
Right? Now use this and see whether you can quickly get hold of that. Or I want you to get V bar is equal to, or I want to get V is equal to omega. How will you get this? V is equal to omega.
You have to take two unit.
Sir, omega bar cross r bar is.
No, don't use the formula from the basics.
Okay. So we can take elemental arcs. Yes, sir. D theta by theta. Yes, sir.
Fine. See, I am again seeing one or two boys responding, and see this quickness must be there because this is what see this students who are answering. See, whatever they have learnt, it is right now on their fingertips. Okay, maybe 3 months, 4 months ago they have learnt. Everybody should train your mind like this, right? Anyways, good friend. Okay, now let me show you one more way of doing. I think I have already shown this to you. What I would do here is I will say R bar is equal to R cap. Agreed?
Yes, sir.
So now dr bar by dt will be d by dt of R cap. Okay?
Yes, sir.
Now in this R is what? Constant. It is the radius.
Yes.
So I will get this as R into d by dt of R.
Yes, sir.
Clear? Okay. Now I'll just rub this and I will elaborate these things neatly for now. Okay.
Yes.
So now you see here, I'll draw a smaller circle here because I need the board space. And if I say this is R bar, then I will extend this. Okay, I'll extend this, I'll extend this. So here I will get what is called as R cap, and this one I will take it as x-axis, and this one I will take it as y-axis. Okay, and I will also draw one more vector here, and I will call this unit vector, and I'll call it as t cap. So there is R cap, there is t cap, this is x and y. And this will make an angle theta, and this is also going to make an angle theta. Okay, hello?
Yes,
Yes.
So if you remember, what is R cap? R cap will be,
radius.
yes, cos theta I cap plus sin theta, right?
Yes, sir.
So now d by dt of r cap will give you minus sin theta I cap plus cosine theta j cap. Okay, you get these two formats. Okay, now I will call this as t cap. Okay, I'll call this by some name. Some name I'll give you. I'll give the sorry, I will not give any name to this. It is just a vector which is perpendicular. I'll give the name to this as t cap.
Yes.
Okay, I'll give the name to this t cap. Now, if I perform t cap dot, okay, sorry, I missed out something here. See, I am differentiate, not, sorry, it should be differentiated with respect to
d theta, sir.
d theta. I should differentiate it with respect to theta. Then I will get it here d theta by dt.
Yes.
Okay. So this one will give me, now this I will write it as t cap omega.
Yes, it is.
Yes, sir.
I don't know.
Say by d theta by dt.
Because see, when you differentiate this, when you differentiate a function with respect to theta, you will have to write this.
But why d theta?
Then, sorry,
dt by minus pi.
D theta by dt means you differentiated dr.
Sir, there in LHS will write.
It should be dr step by dt.
There is. Yes, thank you. That's right.
Yes.
Arun was showing a very frowning face. So
Into direct simply d theta by
and
dt.
then it is d theta by dt. Sorry, thank you.
Yes, sir.
So this and then it is t cap into omega.
Yes, sir.
See, one frowning face from this boy. Okay, fine. So I sense there is something wrong. Okay, you get this, right? Now if I take r cap dot t cap, this is t cap, and this is r cap. So what happens here? Cos theta into minus sin theta. There is minus sin theta here, correct?
Yes, sir.
Yes, sir.
It's clumsy. dr cap by dt is equal to minus sin theta I cap. This I should put it inside. So sin theta cos theta minus sin theta into cos theta will give you minus sin theta cos theta.
Yes, sir. It is.
Okay, and cos theta into sin theta will give you again sin theta cos theta. So this will be 0. What is your inference? The dot product of two vectors is 0. They are perpendicular to each other.
Yes, sir.
Yes, sir.
So if this is r cap, I am drawing a vector perpendicular to this, and now I am going to call it as t cap.
Yes, sir.
Okay. So I got here d r cap by dt. See here, the basic equation was d by dt of r bar. So this is r d r cap by dt. Correct? Hello.
Yes.
So now here r is r and dr cap by dt, what did I get? I got this as omega t cap.
Yes.
Omega t cap.
Yes.
So that means now the differentiation of this is giving me a vector which is in the tangential direction, which is perpendicular to r cap, and that is tangential to the circle.
Yes, sir.
Yes, sir.
Yes, sir.
And this by dimensions and all is representing the velocity in the tangential direction.
Yes.
Yes, sir.
Okay, or I'll write here v t cap. In other words, now I will say that what v is equal to omega r. That's the proof. This is another way of actually approaching this.
So take care of unit vector along the tangent.
Tangential direction. That's what I am saying. It is perpendicular to this and tangential. Got it, friends?
Yes, sir.
Yes.
Now be careful. Okay. So in this case, you see, r is constant because it is moving in a circle.
Okay. Yes,
Nobody is responding.
Yes.
Yes, sir.
See, Because you see, there is sudden silence, I feel, oh, internet connection down, something like that. Okay, fine. So, you see, this is another way. Now, why I am emphasizing this is because, see, if you have taken this, what is this? This is the path of the particle, right? This is x and this is the path of the particle. Remember, we wrote here r bar and theta.
Yes, sir. Yes, sir.
As a particle p. Now, if you say in this context, if you write dr bar by dt, okay, then this result is not same as this result. Because see here, you get r d cap by dt, same like this, plus r cap into dr by dt.
Yes, sir.
And dr by dt is alive. Why? Because the magnitude can change.
Yes, sir.
Yes, sir. Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
So therefore the results will be different.
Oh, yes.
So be careful with that. So dr by dt, you have to handle it with care, depending upon the situation. Okay, you just be calm, cool, cautious, and concentrate on what you are doing and keep on applying the signs. Okay, then you will not miss out anything. Don't be in a hurry. See, at this age, you have got young blood. That you want to do things fast, and if things are working, what happens to most of the students at this age is, if things are going the way you want it, if things are happening the way you wanted it to happen, you will be excited. I'm getting it. I did it. That ahankar sets in you, and therefore the next step you will go to dogs. And sometimes when you are doing something and you don't get the answer, or it is not happening the way you want it, okay, then you will suddenly think, I don't know something, and all you will start. Understand? So both are not good. Okay, so that is why they say in scriptures and all, harsha bandare higga bedi, virasa bandare kugga bedi. Understand? So don't become excited if you are getting result, and don't create that ahankar that I did it. And if you are not getting the answer, don't become dejected. So keep that equanimity and practice this. And this is what is going to give you dividends in the examination, because this temperament is extremely important. Okay, friends, I think I have highlighted and another way of looking at it. All this will be useful in all that we are going to do now. Okay. So I suppose V bar is equal to omega bar cross R bar. That's clear?
Yes, sir.
Right? And here we had some discussion.
Yes,
you see here, V bar is, see now supposing this is the circle. So V bar is like this. Omega bar is out. So omega bar, R
Yes,
bar.
sir.
Omega bar cross R bar, the screwdriver will turn like this, it will go up. That is right.
Yes, sir. Yes.
Right? Now you look at this. Omega bar is this, right?
Yes, sir.
V bar is this.
Yes, sir.
Right.
Yes.
Now V bar is like this, R bar is like this.
Yes.
V bar is like this, R bar. V bar cross R bar. If you do, you will get what?
Minus 1.
Minus omega bar.
Yes, sir.
Yes.
Sir,
Yes, sir.
show that hand movement of
This is the circle.
the circle.
V bar is up,
And
R bar is this.
Yes, sir.
So V bar cross R bar.
V bar cross
Yes, sir.
V bar cross R bar.
Yes, sir.
Okay. V bar cross R bar will give you omega bar this side.
Towards the progress. Yes.
Or
Yes.
towards it. But we have got here V bar is equal to omega bar cross R bar.
R1, yes.
Then where is the fallacy?
Sir, it's a vector.
Sir,
V
V bar cross-
can be parallel to something. However, it can be.
However, Allah,
Then it's parallel vector. Sir. So
what is parallel vector?
V bar will get, sir, we can bring its correctness.
Hengo, this boy.
Sir, we said that V bar
See
cross
now,
R bar is,
listen here. I said here, V bar, R bar. V bar cross R bar. The screwdriver will turn like this. So the vector will go inside, no?
Yes, sir.
Yes, yes.
And what is this vector? Inside.
Minus omega.
Minus
Sir, it is not
omega.
omega bar, sir.
It is not omega bar.
Minus.
Yes, sir. V bar cross R bar is not omega.
Okay, what is omega bar equal to? Wait a minute. What is omega bar equal to? Omega bar equal to what?
Omega into KCET.
Omega bar is equal to in terms of V and R.
V bar into R bar.
Yes, cross
No
product.
sir, no sir. Sir, V bar is equal to omega bar plus
Hey, omega bar is equal to what?
Other sir, V bar into
R bar cross V bar. R bar cross V bar.
R bar cross V bar. Yes, sir.
You will get.
omega bar. Yes sir. Yes.
But will you write like that? Will you write?
right like that only.
Will you write omega bar is equal to? See,
R bar into V bar.
we have discussed this. We have
Omega is V by R.
discussed this.
Direction method.
Sir, magnitude of
So we can only take the directions and magnitude wise it won't be.
See, we got here V bar is equal to omega bar cross R bar. Correct? Huh? Omega bar cross R bar is equal to V bar. This is what we proved. Hello?
Yes, this is correct, sir. This is correct.
This is
Yes,
correct.
sir.
So V is equal to omega bar.
Yes.
Okay. Now, can we write omega bar is equal to what?
R bar into V bar.
No sir, no sir, no sir.
Why?
And now upon you.
Sir, then our expression for magnitude will become VR, sir. But
Ah.
the required expression will be V by R.
Ah.
So it's not.
Yes, sir.
Why?
Sir, only in directions will match.
Direction
Yes,
to match.
direction.
Why we cannot do it? What is the basic reason?
They are not in the
Sir, and also
Just
dimension.
we have to divide.
Sir, a few minutes only we proved that
That makes me incorrect.
it is equal to.
Can we write like this?
No sir, no sir.
No, sir. R cap cross V cap into V by R.
I think all of you forgot.
So it's not a vector. So only for small
There is one boy who remember.
yes.
So omega bar is not a vector.
vector.
Yes, yes.
Understand? We are vectorizing it. It is fictitious vector.
Fictitious vector.
Yes, yes.
So that is why you cannot do like this. That's the point. Understand? We have discussed this earlier. Okay? Keep listening. These are all very important things. Okay? Don't get stressed. So therefore, this is true, but then this is not true. Okay? Even though, because you see, you should not say, oh, P vectors are good, apply cross product. Cross product you can apply only for the real vectors. And this is physics. Mathematics, they'll say consider a vector V1, consider vector V2 or anything. And they will do cross product with everything and anything. But in physics, it means, physically it means. See, the body, please understand, the particle is rotating like this in the anti-clockwise direction. Okay, it is going like this. But we cannot create a bending vector like this. Vectors are always, they are at a particular point representing the magnitude and direction. Okay, and therefore what he said, okay, now we adopted a convention. If the particle is going like this, okay, then we say the vector is perpendicular to the plane of rotation. Okay, unlike if I say velocity vector is like this, that means the particle is having displacement in this direction per unit time. And if I say force is like this, that means force is applied like this.
Okay, sir.
But here it is a convention that we have used. We have created a fictitious vector to okay. Cool student, Aram said you should learn a lot of patience. Okay, and with this attitude you must learn, and you must learn quickly. That's it. And you should not forget anything. Okay, and you can complete a lot of syllabus within a short time. Okay, provided you remain calm and cool. Okay, B angular always tangential, A is acceleration, alpha is angular action, always axial. In the case of angular retardation, yeah. To describe circular particle, we need to specify the reference point, usually the center of the circular reference line, usually the x-axis, axis of rotation, usually z-axis. Okay. Relevance of circular motion in rigid body. Why? Because you see, when a rigid body is rotating, all the particles in the rigid body are performing circular motion.
Circular motion. Yes, sir.
Isn't it? Okay. And the plane of the motion of each of the particle is perpendicular to the axis of rotation.
Yes, sir. Sir, that omega bar is equal to V bar cross R bar, sir. Sir, then even if we take true vectors, sir, A bar cross B bar is equal to square. There also we cannot write like that.
Yeah. There's so many ways we can say that it is not a problem. So many ways we can say it is not a problem.
Yes.
Okay. So the relevance is important because the circular motion of particles is together going to